Hello everyone, welcome to the next tutorial. In this tutorial, I'm going to solve some more gate problems based on the concepts of network theory that we studied before. Okay, so in the first question, let's start with the first question. So a segment of a circuit is shown where VR is equal to 5 volts. So the voltage across VR is given to be 5 volts and VC is equal to 4 sine 2t, and we need to find the voltage drop across the inductor L. Okay, so we know that the voltage VL across the inductor is given as VL is equal to L d or dt of your IL, where IL is the current flowing from this 2 Henry inductor. So let's say this is your first equation. Okay. Also from the figure we can see that like IC will be equal to C d by dt of differential of your VC, where IC is the current flowing from the capacitor of 1 farad and VC is the voltage across it. Okay. So from the equation it is like, so from the question it is given like VC is equal to 4 sine 2t. So it means that IC is equal to C, which is 1 differential of d by dt of your 4 sine 2t. So which is equal to 8 cos 2t. Okay. Now in order to find the value of the voltage VL, we need to apply KCL at this particular node. Okay. So on applying KCL, we can say that like 2 ampere current, okay, 2 plus the current flowing from 5 ohm resistor, which is your 1 ampere, 1 is equal to the current flowing from 2 Henry inductor, which is your IL, plus the current flowing from the capacitor of 1 farad, which is equal to 8 cos 2t. So it means that like IL will be equal to, so IL will be equal to 3 minus 8 cos 2t. Okay. Now using the first equation, we can clearly see that like VL will be equal to L d by dt of IL. Okay. So L, the value of the inductor is 2 Henry. So 2 differential of d by dt of 3 minus 8 cos 2t. So which is coming out to be, or on solving this, we are getting 32 sine 2t. Okay. So the value of the voltage across the inductor is equal to 32 sine 2t volts. Okay. So I hope it is clear how we are approaching this problem. So now let's solve the second problem. Okay. So in the second problem, we need to find the current which is flowing from this inductor. Okay. So we need to find the current flowing from the inductor. Okay. So in order to find the value of the current from the inductor, we need to apply superposition principle. Okay. So after applying superposition principle, we will get this diagram, and in this diagram, like we can convert the voltage sources with a short circuit. Okay. So we have short circuited the voltage sources and we have open circuited our current source. Okay. So now we can find the value of the current which is flowing from this inductor. So it means that like IL1 will be equal to 1 into 1 upon 1 plus j. Okay. Using current division principle. So which is equal to 1 upon 1 plus j. Let's say this is your first equation. Okay. So again, on applying superposition principle and considering this voltage source, we are getting this simplified version of the above circuit. Okay. And we have open circuited the current sources and short circuited our voltage source. Now the current which is flowing from this inductor, let's say IL2 will be equal to 1 upon the total resistance, which is your 1 plus j. Okay. Let's say this is your second equation. Now considering the third voltage source and open circuiting the current sources and short circuiting our voltage source, we are getting, so now the current which will be flowing, let's say IL3 will be equal to minus 1 upon minus 1, because like the voltage source has an opposite polarity. So minus 1 upon 1 plus j. Okay. Let's say this is your third one. Okay. So again applying the superposition principle and now considering this current source and short circuiting the remaining voltage sources and open circuiting our current source, like from this diagram, we can clearly see that like the current flowing from this inductor will be equal to, so IL4 will be equal to your 0 amperes. Okay, so it means that the total current IL, which will be equal to, from the first three equations, we can say it will be equal to IL1 plus IL2 plus IL3. So which is equal to, since IL3 and IL2 are both equal and opposite to each other, so they will cancel out each other. So it will be equal to 1 over 1 plus j amperes. Okay, so I hope it is clear how we are solving this problem. So that's all for today, guys. I will see you in the next tutorial. Please do subscribe to the channel. Thank you.